Hello and welcome to this video where we're going to take a look at how to solve what are called rational equations. In other words, these are equations with fractions or decimals in them. So it's important we're going to combine the skill of how you solve an equation such as x minus 2 is equal to 5, which we've done before, or 3x is equal to 12. For example, we're going to use the same steps where you can separate the two sides. I undo subtracting 2 by adding 2. Whatever I do to one side, I need to do the other. These cross off, leaving me with x is equal to 7. If I have 3 times x, I'm going to undo that by dividing by 3, in which case x would equal 4, and I get my solution. So we're going to combine the skill of solving equations with the adding, subtracting, multiplying, and possibly dividing fractions skills, which we've been working on in this past chapter. So now let's take a look at a sample equation. If I have x plus 2 and 1/3, and that equals 4 and 1/6, I'm going to set it up like the same way I did with the regular equations, where I'm going to divide the two sides. I undo adding 2 and 1/3 by subtracting 2 and 1/3. Whatever I do on one side, I also have to show on the other side. So what that means is that the positive 2 and 1/3 and the subtracting 2 and 1/3 cancel out. So I get x will equal whatever this subtraction problem is. And that's where this past chapter comes in, that the 4 and 1/6 will remain. I have to have a common denominator with the minus 2, and the 1/3 becomes 2/6. So now becomes the skills with the subtracting. So I need to treat this. If I notice my top fraction, 1/6, is smaller than the fractional part of the second one, the minus 2/6. So this is where I'm going to need to borrow a whole, and we're going to need to add the denominator into the numerator. So change the 1/6 to 7/6. So now I subtract. 7 minus 2 is 5. 6. 3 minus 2 is 1. So my x value will equal 1 and 5/6. And if I use my approximation skills, if I have something close to 4 minus 2, it's going to be close to 2. Well, 1 and 5/6 is very close to 2. So that's one example. Another example. What happens if I have x minus 3 and 2/3, and that's going to equal 5 and 7/12? Set it up the same way, split it up. Instead of subtracting 3 and 2/3, I'm going to need to add 3 and 2/3 to both sides. These will cancel out, leave me with x will equal whatever this side is equivalent to. I have to have like denominators, which in this case is 12. So it's 5 and 7/12. I'm going to add 3. 2/3 out of 12 will be 8/12. If I add, I get 8 and 15/12. Well, I need to remember that 15/12 will be another 1 and 3/12. So I need to add that onto 8. So in this case, x will equal 9 and 3/12, or 9 and 1/4 if I reduce that. So I get my answer. When it comes to dealing with multiplication, this can get a little trickier. If I have 2 and 3/4 times x, and I know that will be equivalent to, let me think, let's say 11/16. I'm going to take the 2 and 3/4 and change that to 11/4 x. It's going to equal 11/16. I'm going to take this, multiply by 4 11s on both sides. These will cancel out. The 11s will cancel out. The 16 can reduce. I get x is equal to 1/4. Let me clarify what I did. As I mentioned in class, one of the quickest ways of solving these multiplication problems, where if I have this mixed number times this variable, I am going to take a look at this and say, okay, what happens if I have 11/4? Instead of going through and saying dividing by 11/4, which is completely understandable, one way to get around that is to do something called multiplying by the reciprocal. So if I have 11/4, I'm going to flip that fraction. It becomes 4/11. Whatever I do to one side, I am going to do to the other side. So what ends up happening is the 4's cancel, the 11's cancel. So what that does is that removes this part from the equation completely, leaving you with just the x by itself, and it works over on the other side. If I use my skill from before of using the division, let me model that. 2 3/4 x is equal to 11/16. Once again, you're going to need to change that to 11/4 times x is equal to 11/16. You're going to think about dividing by 11/4. I'd encourage you to write it as division this way when you're dealing with the fractions. So you still need to change the mixed number to an improper fraction. It's going to leave x by itself. I'm going to use the keep change flip rule. Becomes times 4/11. You're going to simplify here with the 11's. You're going to simplify the 4 and the 16. So x will end up equaling 1/4. Okay, so that is another way of getting my answer. What you will notice is what I have up here in green and what I have down here in green end up being the same exact problem in the end. Just this method saves a lot of remembering what you do with the division of fractions. And just as a review, we did these types of problems before, but they're going to come out again. What happens if you have x divided by 5 is equal to 4? Once again, to undo dividing by 5, I'm going to multiply by 5. Okay, it becomes 5/1 in a sense, times 5. The 5's will cancel, leaving you what x will equal 20. Where this indeed comes from is another way of saying x over 5 is to say 1/5 of x. So once again, you're dividing by 1/5 or you're multiplying by 5/1. Okay? And those will end up canceling. So hopefully this has been a helpful little review of what we did in class. And hopefully it'll be you seeing that we're taking the skills of when we solved equations and now applying them with working with fractions. They look a little more complicated, but you know the skills of how do you solve the equation and then how do you work out that problem with the fractions in the end. So good luck.